Reading is stable, 4,500 kilograms on the mark.
Good. Log that for the Z-20 actuator line.
The density is exactly where it needs to be for the Z-20 brackets.
Confirmed. Crystalline structure is perfect.
This tracking shot highlights the transfer of Z-20 structural components, emphasizing the critical transition.
Final acceptance gate closed. Check the integrity seal on the Z-20 flow.
Seal is green. All materials certified.
The alignment is perfect.
Verified.
Optical loss reading is 0.0001 deci, well within tolerance for the Z-20.
Confirmed. The cleave is perfect.
Torque reading is stable at 50 Newton meters.
Confirmed. Alignment is perfect.
A technician carefully secures the miniaturized, high-torque servo motor assembly into the Z-20 primary flight.
Ensure the fiber optics are seated correctly before I secure the harness.
They look good. Clearance is tight near the casing.
Confirmed, everything is aligned for the Z-20.
The Z-20 primary flight control actuator unit undergoes rapid thermal cycling, modulating between extreme
Check the alignment on the actuator mounts for process A.
Looks good, but we need to verify the wiring harness clearance before the robotics engage.
In the Z-20's rotor mast bay, robotic automation pre-drills the actuator mounts. This micromillimeter precision is a
Connection secure on the primary linkage.
Gauge reading confirms 0.01 degrees of tolerance. Length is set.
The schematics look good. We are within tolerance for the initial surge.
Agreed. Initiating the sequence now. Power stable.
Check channel 4 resonance.
Levels are stable. Process B confirmed robust installation.
Look at the fluctuation on the PFD actuator readout.
It's within tolerance. Overrides are nominal. Confirming process B success.
The actuators ensure pitch control, while the team manually secures the massive blade root bolts.
These systems provide the input data, like GPS and airspeed, that the flight control computer uses to stabilize the aircraft and command the actuators.
There's a slight ripple right here. See it under the light?
Yes, logging the coordinates now. It might be minor, but we flag everything.
The precise alignment of the twin turboshaft engines is critical, as their power will ultimately control the main rotor system.
This interface is vital because the FBW system must manage engine torque in conjunction with rotor pitch commands to maintain stable flight.
Pressure is steady at 50 psi, but look at the flow rate here.
I see it. The system integrity holds. Updating the log now.
From raw titanium ingots to the finished Z-20, the assembly process is complete. The aircraft is now ready for flight testing.
Latch is secured on the starboard side.
Confirmed. Main rotor actuators clear. Checklist complete.
Strapped in and secure.
Roger. Initiating flight control check.
Positive response on all axes. Systems go.
During this simulated emergency climb, the Z-20 is at flight planning control and had G-load.
The fly-by-wire response was crisp. Let's verify the actuator logs.
Running the process B validation now.
Confirmed. All parameters within specification.
The final stage ensures the integrity of the fly-by-wire system during transit.
Clear on the heat shrink. Move to the tail section.
Sierra Golf 1, transport approaching hangar bay.
Roger that. Gate confirmed clear.
As we move to the cockpit, note the fly-by-wire system. These flight control actuator units ensure unmatched stability and precision.
Bay door secured, Chief.
Fuel lines connected and checked. Rotor engagement sequence initiated.
Showcasing high performance and agility, the Z-20's flight control actuators handle extreme stress, making it fit for demanding utility roles.
Cable deploying now.
Roger. Pilot, going down.
Maintaining stable hover. Be advised of the wind shear.
Pilot, maintaining stable hover. Hoist extending, approaching pickup point.
How are the servos looking?
Green across the board. Ready for next cycle.
The responsiveness is incredible. Absolutely no delay on the cyclic stick. It handles complex maneuvers with smooth authority.